Good morning. How are you doing? Thank you for joining me. My name's Elton. I'm a Microsoft MVP and I'm a Pluralsight author, and I work for Docker. I'm going to talk to you about Docker today in Linux and Windows. I usually ask the same few questions. I assume you've all heard of Docker. Can you raise your hands if you've used Docker on Linux? And if you've used Docker on Windows with Windows containers? And if you've used a hybrid swarm with Linux and Windows? Shame, because if someone had put their hand up, they could do this for me. So that's fine. That's what I'm going to talk about today. It's how you can run a mixture of Linux and Windows applications in a single swarm. So the advantage of that is you have a single deployment model, a single management model. You don't really care whether it's Linux or Windows. You can take all this great stuff that's out there in the open source world. You can bring it into your application without having to read a book this big about Linux and grow a big beard. You don't have to do that anymore. OK, so this is what I'm going to go through today. I'm going to start by talking a little bit about Linux and Windows containers and explaining why you can't just run a Windows container on a Linux machine and vice versa. So we're going to go into the details a little bit about how Docker containers actually work so you can understand why you can't just run anything anywhere. Then I'm going to spend a little bit of time talking about why this cross-platform stuff is really useful. Why it's worth, especially if you've got a Windows background, like me, I've spent 15 years writing .NET apps on Windows, why it's actually worthwhile investing some time seeing what's out there on the other side of the fence. The Linux stuff, the open source stuff that's enterprise-grade stuff that you can bring into your application. And then lastly, I'll show you how to do it. So I've got a Docker swarm running in virtual machines on my laptop, some Windows, some Linux, and I'll show you how you can start with an application that's all Windows containers and move bits of them over to Linux. So, Linux versus Windows. Now, you've all seen the Microsoft loves Linux slide. Well, yeah, that's great, but Windows and Linux are fundamentally different operating systems. So the file system is different, the way to manage processes is different, how you actually start a process is different. Those are all important things. And it's just the same for containers as it is for ordinary processes. Like you can't download OpenOffice for Linux and run it on your Windows machine. It just doesn't work. Same as if you copied winword.exe to a Linux machine and tried to run it, nothing would happen. They don't know how to talk to each other. And the same is true with containers. So in the Windows world, if I were to package my application up in a Docker image, so that's the package that I can run a container from it, I'd run a command like docker image build, and Docker would run through all the instructions in my Docker file, and it would produce an image. And that image at the end has got everything my application needs. It's got my application with all its configuration. It's got ASP.NET. It's got the right version of the .NET framework that I need. IIS, all built on top of Windows Server Core. And that image will only run on a Windows Docker host. Now, in the Linux world, the process is the same. The Docker commands are the same. I'd still run docker image build with my Docker file, and then Docker would produce an image, which is the package of my application. But in this case, I've got a Linux application. So I'm starting from Ubuntu. I'm adding in the JDK for a Java application. I add in Tomcat, and then my app with all its configuration. So the principles are the same. I've got this image, which is a package of my application, but this image is a Linux image. It's only going to run on a Linux host. And the reason for that is when you start your application with Docker container run, you give it the name of the image you want to run. On Windows, what it will do is it will start the process of your application on the host. So the container thinks it's running in its own little server, but actually all the processes are running natively on the host with this logical boundary around them so they can't see other processes. That's what the container is. So the only way I can run my W3 WP exe is if I've got a Windows host to run it on. And the same's true on the other side, on the Linux side. I've got my Linux-based image. To run Tomcat, I need to have a Linux server that can understand the file system in the image and understand how to start and manage the process. I can't just take my Windows image and try and run it over here because it's never heard of an exe. It doesn't know what to do with it. It doesn't know how to manage it. It probably can't understand the file system. So fundamentally, I can't run that application on a different platform. But Docker itself is cross-platform. It's written in Go. There are some bits of it that say this only works for Windows and this only works for Linux, but fundamentally, it's a single code base, and that's true of the command line as well as the back end, the service that runs on the host. So I can take my Windows my Windows client running in PowerShell, and I can manage a remote Windows host or a remote Linux host running Docker. Doesn't matter. I just connect to it and I talk to it in the same way. And vice versa. I can run a Linux client command line and I can manage my remote machines in exactly the same way. And the backend, the service, so in Windows it's a Windows service, in Linux it's a daemon that sits there and runs the containers. Those backend machines can talk to each other as well. And that's what we call a swarm. A swarm is just a cluster of machines that all have Docker installed, and you manage them as a single unit. So your command line, your client says Docker whatever, and it's actually talking to the whole swarm. And the swarm, if you tell it to run a container, the swarm will decide where to run it and make sure it stays up, that sort of thing. And that swarm can be a mixture of Linux and Windows machines, which is where you get this notion of a hybrid, where my application could be consisted of Windows and Linux components, and I don't care where they run. I'm just going to tell the swarm to run them, and it will run the Linux ones here and the Windows ones there, and the containers on different hosts can all talk to each other over a virtual network, and all benefit from the same security you get with the secure communication between the swarm, and the scalability, and the high availability, and all that stuff. So why would you want to do all this stuff? It's because there's nothing wrong with Windows, right? I've been doing everything in Windows for years. There are 3 reasons. This isn't a Windows bashing session, not at all, but there are things in the Linux world which are worth taking advantage of. And the first one is cost. So if I were to have a really basic swarm with a manager and a couple of worker nodes, and I wanted to run that in Azure, it's going to cost 5,000 krona a month for a fairly modest set of machines. If I can change my application to make use of Linux parts, where I've got open source parts, and I can use the Linux manager as well, then instead it's going to cost more like 3,500 krona. So that's for a really basic swarm. The saving is like 1,600 krona a month. It's very nearly enough to go out to a restaurant and have a meal in Oslo. But you wouldn't have a small cluster like this. So if you're running production stuff, you would have high availability for your managers. You'd have at least 3 nodes. You want at least 2 nodes for your Windows part. So you're probably talking half a dozen machines. Your bill would be 5,000 krona a month instead of 10,000, something like that. So cost is a fairly significant factor. The second one is choice. So there's software in the Linux world that just doesn't really work in Windows. So Nginx is a web server that's very popular in Linux. It can run as a web server for itself, or it can run as a proxy for your web server. So if I've got my ASP.NET application, one of the easiest ways I can boost performance is to put a proxy in front of it. The proxy caches anything static, like images and CSS that my app doesn't need to serve. And I can do SSL termination in the proxy and all that sort of stuff. Nginx is fantastic for that. Redis, which is a key value store. You can use it as a lightweight distributed database. It's also got publish-subscribe mechanisms, so people use it as a simple message queue. And GitLab, which is it's like running GitHub on your laptop. It's got all the mechanics for a Git server, but it's also got CI built in. It's an excellent piece of kit. These all emerged from Linux. They're all open source. They all work fine in Linux, not so much on Windows. So Nginx explicitly say, you can run it on Windows, but it's kind of like beta. Because with Linux, you can get really deep under the covers and tune things for performance, which is what Nginx does. You can't really do the same thing as they need to do in Windows. With Redis, a while ago, Microsoft made their own port, so you could run it on Windows, but it kind of hasn't kept up with the mainstream development, and it's just kind of sat there on its own. And GitLab uses Redis and Nginx, so they don't run on Windows either. So having this choice to bring this stuff into your application is really valuable. And the last thing is about stability. So I don't know if you've seen a similar graph to this. When Microsoft were releasing Windows Server 2016, and alongside that, Nano Server, the cut-down version, they did this retrospective analysis of the previous 12 months' worth of Windows updates and looked at how many needed a reboot of the machine. So you do a Windows update, I'm going to take your machine down and bring it back up again, good luck. Well, often that happens when you're presenting, which is why I use a Mac now. What they found was, for that 12-month period, if you're running full Windows Server with a UI, which you shouldn't do, because your server shouldn't have a UI, it would have rebooted 11 times. So on average, every month, it's going to go down, or tell you to take it down. You've got to plan in whatever applications are running and sort that out. If you're running Windows Server Core, which you should be doing, because your server shouldn't have a UI, it would have been 6 times every other month. Nano Server, even smaller, 3 times. Nano Server doesn't run the full suite of Windows apps, so you can't run .NET Framework apps on Nano Server, so I'm focusing on Windows Server Core. So 6 times it reboots. Over the same 12-month period, my Ubuntu server doesn't reboot at all. It still gets updates, and you can still manage that, and it's still got security patches. But because of the components and the way that Linux works, rebooting because of an update is incredibly rare. So you get this stability of knowing that when your stuff's running up there, you're not going to have to worry about regular reboots. So it's cheaper, you've got a wide range of stuff, and it's going to be up for longer with less interference. So that's why it's a good thing to be able to look at doing. So that's mostly it for the slides. So it's all mostly demos from now on. My demo application starts off with a whole bunch of Windows containers. So the starting point for this is actually the end point for the session I did at NDC London. If you want to see how I got here, then you can go to Vimeo and you can watch that session. I had long hair then and no beard, but it is still me. I had a Docker t-shirt, so you can tell. What this is, these are all Windows containers. I've got an ASP.NET Web Forms app, which I start off with. It's just a big old monolith, and I put it into a Windows container. And then I start breaking features out and put them in other containers. So what it happens is it's like a sign-up application to register your interest. So you put your details into the web application. It drops a message onto a message queue. There's a handler here that picks up that message and saves your data in SQL Server. And there's another handler that gets a copy of the same messages, and it saves the data in Elasticsearch. And right at the far end there is Kibana, which is a analytics tool on top of Elasticsearch. So the idea here is I've fixed my performance problem by putting a message queue in here, so this thing scales really nicely now. I've got a handler that deals with my transactional database, SQL Server, and I've got another handler that deals with my reporting database, so my users can go and get their own data without having to talk to me. So that's fine. Like half of those are Linux compatible or emerged from Linux and have been kind of ported over to work in Windows. So the message queue I use is called NATS. It's open source, like ludicrously high-performing message queue written in Go. SQL Server even runs in Linux now. Elasticsearch is Java. That obviously runs in Linux. And Kibana is a Node.js application. So that obviously runs on Linux too. So what I'm going to do now is I'm going to start from the point where everything's running in Windows. I'm going to move the stuff over so that the Linux-compatible bits and pieces run in Linux containers. Blue means Windows and orange means Linux, if you haven't guessed the color scheme. Okay, so that's what I'm going to be showing you. So that's what we're doing for the rest of the session, showing you how that stuff works. So what I've got here on my Mac, I've got 3 virtual machines that are all server operating systems just running Docker. That's all they've got installed on them, Docker. 2 Ubuntu machines and a Windows Server 2016 machine. And in this console here, I'm connected to my swarm. So they're all joined together in a swarm. To create the swarm, all you do is you run Docker swarm init on one machine and Docker swarm join on the others. So I've already done that. So what I've got here, if I look at the Docker version command, that tells me that my client at the top there is Darwin, so that's running on my Mac. And the remote server that I'm connected to, which is my VM, is Linux. So that's my Linux machine. So that's fine. What I can also do, because it's a swarm, is I can look at the nodes. That's all the machines that are joined in the swarm. And I can see that I haven't been consistent with my naming schemes, but I've got a bunch of machines in there. Any resource in the Docker world has like a friendly name, like my UB16 name, and an ID that Docker randomly generates. And you can use either of those. For containers and nodes and images, they all have that sort of 2ID principle. And I've got one service running at the moment, which is called Viz. It's the visualizer. And all that is a little tiny sample application that looks like this, that shows you the containers in your swarm. So this is a visual view of what I can see from the Docker API. So I've got my 3 nodes. I'll go into what those labels mean in a little bit. And I've got one container running, which is this application, the visualizer. So when you start building up a distributed application in Docker, you'll start off with a Docker compose file. A compose file just describes all the different components and how they fit together. So what I've got here is a big lengthy compose file that describes all of those containers that I've shown you. This is all up on GitHub. You have to follow me on Twitter, and then I'll tell you where the link is, so you can go and play with this yourself if you need to. The interesting thing about this is all these images, all these wrapped up packaged applications, they're all public and they're all on Docker Hub too. So if you want to run this application, you literally just need this file. and you do docker stack deploy, it'll pull down all the images it needs, and it'll run them wherever it needs to run them. If you can see that, the database credentials in there in plain text, yeah, I know that's not very good. There's a much better way of doing that, but this is a nice, quick way to show it. The interesting thing about here is I can put a constraint to say, I only want this to run on a node where the platform OS is Windows. And Docker works that out for me. It knows that this node is a Windows node. I don't have to do that. So when I run this, Docker will go and get the image. It doesn't know from this image identifier whether it's Windows or Linux. It'll grab the image, and then it might find that it can't run it. So it will try, maybe one of the Linux nodes will pick up the request to run that container. It'll download 10 gigabytes of image and then say that it can't run it. So rather than let it do that, this constraint is just a hint that says, this is a Windows thing, run it on Windows. So that's how you would normally do it in production. What I've got here, to make it simpler and a little bit easier to follow, I've got a bunch of scripts that do exactly the same thing. So for each of these, I'm creating like a virtual network. The overlay network means it can span all those nodes, whether they're Linux, Windows, doesn't care. And then I'm creating these services manually. So what I'll be doing is I'll be replacing those services, so it's an easy way to see what's going on. So I've got my SQL Server database here. I've got Elasticsearch. I've got NAT, my message queue. I've got my web application, my handler for SQL Server, my Elasticsearch handler, and then Kibana. OK, so that's my full application stack. So what have I got here? So run 01 to create my services. And it'll just spout out a lot of random IDs for each of the things that it's creating. So if I flip over to the visualizer, we'll see that these containers are popping in now. So there's my database, message queue, index handler. They go green when they're ready to run, and they're red when they're starting up. So what we'll see here is a few of them are still red because they're just getting themselves started. It's quite heavily unbalanced, this swarm. So there's nothing running on my central node. There's one thing on my left-hand node, and all the other stuff is on my right-hand node because they're all Windows containers. They can only run on this Windows node. So that's all up and running. The web application is still red because it's got a health check in it. So a health check is a way that you can tell Docker, you write it in the Docker file, how to test if the application's healthy. So not just whether it's running, whether it's actually healthy. And I've got a health check in my web Docker file that says every 5 seconds, ping the local host so that the health check runs inside the container. So there's a PowerShell command that says ping the local host, and if the response is 200, then everything's OK. And if it's not, then something's wrong. And then Docker will take evasive action. So if my web application kept failing the health check and I had another Windows node, Docker would take it down and bring it up somewhere else. It's just gone green, which means the health check has passed, and my whole application stack is ready to roll. So let's have a look and see where it is. So I've got my nodes here. If I inspect ZMU, which is my Windows node, I can see the IP address of my virtual machine, just so you know there's no fakery involved, not that you would suspect me of that. So when I browse to this, this is my demo application. So don't worry too much about it, other than the fact that there's a blatant advert for DockerCon, which is coming to Copenhagen in October. The application itself isn't particularly interesting. What you do is you click on Sign Up, and you get some stuff where you can put your details in. So I'll put my name and other bits and pieces in here. And what's interesting about this is these drop-downs, so I'm in Norway right now, these drop-downs are populated by the application itself. So it uses Entity Framework code first. So when it first connects to the SQL Server running in a container, it could also connect to a SQL Server running somewhere else, or SQL Azure, it doesn't matter. This happens to be running in a container. It's got a completely empty instance of SQL Server. So it deploys the schema first, and then it deploys all that seed data. So when I get to that screen, I know it's all working, because otherwise that wouldn't have happened. There's no delay when I first launched this web application because of the health check. The health check had kicked in and effectively already warmed everything up. So it started the worker process, it did that entity framework deployment, everything was ready, so the first user doesn't hit a cold application. It's already running and ready to go. So that's my application, so that's fairly straightforward. And also on here, I've got Kibana running. So I should be able to browse to the same IP address, but port 5601. And I should see Kibana. And Kibana is just this, just the front end that comes on top of Elasticsearch. It understands about Elasticsearch, and it expects to find when it's packaged up, it expects to find a container called Elasticsearch. So all I have to do to use it is make sure that I call my container Elasticsearch, and it will find it. And that's what's happened here. So I've already put one piece of data in there from when I did my sign up. That's gone through the message queue. One handler's picked up and put it in SQL Server. The other handler's picked it up and put it in Elasticsearch. So when Kibana connects, it can see all the data fields because there's a piece of data already in there. And when I click on Discover, I can see my first prospect signed up that I put in there. So that's all up and running. So that's cool, but it's all running in Windows. So we're going to start shifting this around. Now, in my second script, I'm going to get rid of my Kibana service, get rid of Elasticsearch, and create some replacements. So let me start that up, and then we'll have a look a bit more closely at that script. So on my visualizer, we'll see, it's already happening. So Elasticsearch and Kibana now have moved from my Windows machine onto, it just happens to have gone into the middle node. It could be any node. So when you schedule a container to run or a service to run, Docker Swarm will look at the nodes that are applicable, and it will say, yeah, this guy's got capacity from CPU and memory point of view, I'll schedule one in there, and it will monitor them. If I were to kill this VM now, those would move over to here, because the Swarm makes sure that my service level is what I request. So this script that I just ran, the big difference here is that I'm using a different constraint. I'm saying that we need to run on Linux, and I'm using the official Elasticsearch image rather than my own Windows image that I've knocked up one evening when I had nothing better to do. Same with Kibana. So I'm using Linux, and I'm using the official image, which is kind of looked after by people at Docker. So I've got a more resilient set of components here, and they're running on Linux, but fundamentally, they're the same thing. So when I want to see what's going on, I can do a Docker service list, and I see them all running. Some are on Linux, some are on Windows, doesn't matter. If I want to see what's going on inside there, I can do a Docker service logs, and I could look at, say, my index handler, v7. And these are the logs that come out from my console application, which is my message handler. It tells me the node name, so if my container moves around, or if I've got several containers, I can see the logs from all of them. And if I do the same for my Kibana, and have a look at the logs, where is Kibana? QWW. Then I can see the output from the node logs that Kibana writes. So this is a node application running on Linux. I'm going to manage it in exactly the same way as if it was as I do with my .NET application running on my Windows node. I don't care about that. I don't have to get down into the world of Linux and understand how to deploy this application, how to manage it, and how to look at it and look after it. It's just a container. Okay, so if I go back to my web application, so this hasn't changed. This is still running on my Windows machine. So if I put in a new piece of data and click on Go, this works in the same way. If I try and refresh in Kibana, that's gone because this is on my Windows machine. So there is nothing listening at 5601 now because I've moved that container off. That's a Linux container now. So back to my visualizer, that will tell me I should be on node 2 for Kibana. And again, I can just do a list of my nodes and inspect the Kibana node, which is SY38. And that's the address of the node where Kibana is running. So I should be able to point to that and get exactly the same experience. 5601. Okay, so it looks the same because it's the same version of Kibana. The UX is the same because it's still talking to an Elasticsearch container called Elasticsearch, but this one happens to be in Linux. I could have moved them one at a time, but this way is easier. And when I change this to be prospects, again, I've already got some data in there. So it sees all the fields. I click on Discover, and I've got one piece of data, which is my 222 that I've just put in. I've only got one piece of data because the previous Elasticsearch instance that was running on Windows, that's gone now. The data that was with it's gone too because of the way I constructed that Elasticsearch service. Losing your data isn't great, obviously, but there are other ways to manage that. So Docker has this notion of volumes, like a data volume, which is separate from a container. So I could have a volume containing all my SQL Server data, another volume with all my Elasticsearch data, and then if I move my Elasticsearch container, as long as it can reach the volume, all the data stays intact. So at the moment, we don't have a way of, built in with Docker Swarm, we don't have a way of having shared state across different nodes. That's coming next year. But you can use a volume plugin for something. If you're in a data center of your own, like HPE have a shared storage component that works with Docker. Same with Cisco and the other guys. Up in the cloud, you can use shared storage component like Azure File Storage or whatever works for you. Soon, that will be part of the platform itself. Okay, so my first piece of data is gone, but actually everything's still working, which is pretty cool. I've cut out the reporting side of it, and everything's continued to work as I kind of hoped it would. So the next thing I'm going to do is I'm going to replace the message queue. So same principle. I'm going to run this script that gets rid of the message queue, starts a new one using specifying Linux and using an official image, which is a Linux-based image. So back here, let's clear this out and do 03. And check the visualizer. And yeah, so the message queue now has hopped onto node 1. And the load on my Windows node is going down now. So now I've only got things which traditionally belong on Windows. So I've got my ASP.NET application, my web application, my message handler is a .NET framework console app. So it's all full .NET, it has to run on Windows. And of course, I've got SQL Server on there. On my Linux nodes now, I've got Elasticsearch and Kibana and this message queue, NATS. That's cool. They all run on Linux. They're all much more lightweight. You saw how quickly they started up, which is another side effect, is that Linux images are much smaller than Windows images, and Linux containers start more quickly than Windows containers. So a Windows container will still start kind of sub-second, but a Linux container will start in milliseconds. OK, so that's all looking good. So now my application should still work. So if I replace this with some 3s and click on Go, there's going to be a lag. And the reason there's going to be a lag is because my web application has got a connection pool that it keeps for connecting to the message queue. So that's just a part of how that particular component works. So it's gone through now, so that's fine. The reason it wasn't as fast is because it's picked up a connection from the pool, it's tried to use it, and of course, it's gone. The virtual IP address for my message queue has changed because it's in a different container now. So it ditches that connection from the pool, it goes back to Docker to find out the IP address for the new container, which is moved on to Linux. And once it's got that, then the message goes through. So part of what you're doing when you start moving stuff to Docker is thinking about resilience. So making sure that if you're using a component that expects a separate component to be able to answer, that it's got stuff like retry logic to deal with the fact that maybe that container's moved or maybe it's gone down and it's going to come up again in a few seconds. Just like when you move your, if you move to Azure and you're using a SQL Azure database, if you're using Entity Framework, you would use the SQL Azure connection provider that does all that retry stuff for you. It's the same principle. In fact, I use the same connection provider in this application because I can't guarantee that SQL will be available when my application starts. So those sorts of bits of retry, they tend to be the only application logic that you need to change when you move to Docker, because you can run anything in Docker. But if your application expected the database to always exist and always be up, and expected the message queue to always exist and always be up, and never retried, then your application will hang, and Docker will start a new container for you. OK, so that's gone through. If I look at Kibana and click on Discover, so there's my new entry gone through there. So everything else stayed the same. The message handlers carried on listening to the message queue. They did the same process that we saw the web application do. So the next time the message handler went to the queue and said, have you got anything? The queue's not there anymore, so there would be a lag when it goes and finds the new queue, and then it brings it forward. OK, so that's pretty cool. And again, the management of this stuff is all the same. So running my services now, if I have a look at my message queue, so if I do a Docker service PS, that lists me all the tasks in the kind of history of my message queue. It's going to show me I've got one message queue, and it's running on my Docker instance. And if I look at the logs for, what did I call it, 3AW? Oh, service logs. Then I'll see that these are the logs that come through from my container that's running my message queue on Linux. So we've got all the data there from that message queue. That's a Go application. It's writing to the console again, but as far as Docker is concerned, it's just something that's writing to the console. It doesn't care that it's Go on Linux as opposed to Go on Windows or .NET on Windows. And the same with my message handlers. So if I look at the service logs for my Elasticsearch handler, which is V7, then it's showing me it's initialized Elasticsearch, connected to the message queue, it's received a message and indexed the prospect. So it tells me all the stuff that it's doing, and there are no error messages in there. So as it happened, it connected when my message queue moved away, and when Elasticsearch moved away, the reconnection logic worked fine. So it doesn't log any errors. If it had errored, then if the console application had errored and exited, then Docker would just start a new container, and that would connect to the new services. So even if my application is not resilient, then the platform is resilient, and it will take care of some of that stuff for me. OK, so now, where are we? The last one is a bit scarier. So I'm going to replace SQL Server with SQL Server running on Linux. So SQL Server on Linux, it kind of just works in the same way. Whenever I run this, I expect it not to work, but it always does. At the moment, we're in Community Tech Preview 2.1. But at Build a couple of months ago, Microsoft said when SQL Server 2017 lands, it's going to come out on Windows, Linux, and Docker all at the same time. So it's interesting to see what you can do with this stuff. Under the hood, it uses the same file format and all the same semantics. So there's no difference from a client perspective connecting to SQL on Linux or SQL on Windows or SQL in Docker. So I could connect my SQL Server Management Studio on my laptop into any one of those hosts, and it would work in the same way. OK, and the other thing I'm going to do is I'm effectively restarting my web application because of that entity framework code first business. My web application is currently connected to SQL running on Windows. When I first started my web application, it found an empty database, deployed the schema, deployed the seed data, got everything up and running. I'm swapping the database out from underneath it without telling it. It's not going to try and recreate the schema. So I could still push the button and send the data through, but nothing's going to happen. If I refresh it, it's not going to find the schema with the seed data or anything like that. So I'm forcing it to do an update. Excuse me. So it will find the new database, and then it will, as part of the health check, it will recreate the schema and deploy the data. So that's number 4. And on my visualizer now, I've got my database running on my Linux node. Now, one slightly unusual quirk about SQL Server on Linux, especially at the moment with CTP, is that it needs at least 3 gig of RAM or it won't start. And that's why my workers all have slightly odd amounts of RAM. So my manager is a Linux manager. Managers don't have to work very hard. So, well, you all know that, right? So it's the same in Docker. So my manager has got 1.94 gig of RAM. That's not a recommended amount. That's just the amount that this one's got. My Windows node is 2.6 gig of RAM. And my other Linux node, my other Linux worker, is 3.3 gig of RAM. Now, I want to make sure that my SQL Server database lands on this node because I want to make sure, or another node that's got enough RAM, otherwise it just won't start. So that's what this stuff here is. This RAM equals S, RAM equals L, RAM equals M. Those are node labels that I've added to my swarm. So you can add like any arbitrary stuff you want to a node to identify it. So I don't need to say that this is Windows and this is Linux because Docker can tell that for itself. But if I want to say that this guy's got a small amount of RAM, a medium amount of RAM, and a large amount of RAM, 3 bears style, then I need to add an arbitrary node. And that's what I've also got in my script. I've got 2 constraints. One constraint saying this has to be Linux, and one constraint saying it has to run on a node that's got the RAM label set to large. If I had multiple Linux nodes running, multiple VMs that were actually running Docker service in the same swarm, and they all had large RAM labels, then it would choose amongst them depending on how hard they're working. As it happens, I've only got 1. I haven't got enough memory on my MacBook to run like 5. OK, so that's where we are. So that's what we've got now. So this is much more even. The visualizer was the thing that we started with, and then deployed everything on Windows, and now I've moved things around. So I'm getting a better share of compute resources, and maybe in the real world, I could maybe scale down my Windows machine now. It doesn't have to work so hard, and I've got my Linux machines that are sharing the workload. So now when I go back to here, if I go back to the home page, what was it, 8? So that's working still. When I click sign up, I can see my seed data. So it's obviously done its stuff. Again, there was no lag because of the health check. It kicked in and it deployed all that stuff for me. I don't get the first hit, but it's deployed everything that it needs to deploy. and it just happens to be working on Linux, which is always the point where I think, this is highly unusual that just works. Okay, so let's put this stuff in again. The rest of the application is the same. It's running on the same components elsewhere, so it still behaves in the same way. My Kibana, I haven't replaced Elasticsearch, so now when I click on my Discover, I should see the most recent one. Where are you? So there's my 444. And also now, that will be saved in SQL Server on Linux. So how can I show that that is definitely in Linux? Well, let's have a look here. If I do a look at all my services, so I can see I've got my database now, which is running on SQL Server Linux CTP2. And if I look at my save handler, which is called OGS, Docker Service Logs, OGS, then I will see my incrementing IDs. This is an identity column for my prospect ID. It goes 1, 2, 3, and then it goes back to 1 because it's hit a completely new database, so it's a new prospect. If that's not good enough, I will attempt to connect to it from Visual Studio Code. So Visual Studio Code, excuse me, has this really cool plugin for SQL Server, and what you do is you do SQL, and I can connect, and it's on 55.11. So I've already set that up. And if I have a look at the output, it should show me that it's connecting, hopefully. And I should be able to execute this. Hey, cool. This plugin doesn't always work. So what that's doing is it's connecting to my virtual machine, which is the central node that's running SQL Server at the moment. Because of the way I've deployed that container, because of the way I did this, I've exposed the port that SQL Server listens on. So I don't need to publicly expose a port for my containers to talk to each other. So my SQL Server container has got port 1433 open, so my web container can talk to that, that's fine. I don't need to publicly expose it. But if I do publicly expose it, the things outside can talk to the host on that port, and it kind of tunnels through into the container. So that's what I've done here. I've run my SQL query connecting to my virtual machine on port 1433, but that port is being listened to by Docker. So it's routed the request into the container and sent back the response. So I can see my prospect that I put in there with my 444 details, and this query, which was always pointless up until now, getting your host info in your operating system, because it always just said Linux, it always just said Windows, but you can prove they haven't hard-coded it because now it says Linux, and it tells me it's running on Ubuntu 16.04, which I wouldn't necessarily know just by using the container. So that's Linux running my SQL Server instance now, and I've moved kind of everything that I wanted to move over to Linux running in the same swarm. Okay, so that's the beauty of being able to do this stuff. So if you wanted to maybe trial SQL Server on Linux, then this is a great way of doing it. Without having to go and work out how to actually deploy it and dealing with your init system, and which will be different for every flavor of Linux. You don't have to care about that stuff. I can just run it in a container, plug it into my system with all the rest of the things that I have running, and everything will just carry on talking to each other in the same way. Okay, so back to some slides. Any second now. Cool, so that was the end point. So we got there without any kind of hiccups. The application didn't always stay available, but then I'm tearing the insides out of it, and I'm running in a kind of demo mode. So I'm not running in a way that allowed me to replace the database or replace Elasticsearch and maintain the data. So, but you can kind of do that. So if I was to set up on if I was running on cloud machines instead of on my local machine, I could have a shared storage layer, and I could potentially take down my Elasticsearch instance on Windows, bring it up on Linux, pointing to the same data store, and all that data would carry on being there. The only real lag from an operational point of view is when I switched out the message queue, because the connection pooling here, a kind of caching mechanism that expected it to be on the old container, but built into the NuGet package that I use for NATs, it's already got the ability to try again a little bit later on. So it waited a few seconds, then it found this one, and it pushed that through. These guys got those messages without any problem. And then the big problem was SQL Server, because of the way I'm deploying my database. So I'm just using the base SQL Server image from Microsoft. I'm not doing anything to it because everything is done by my application. That's one way, and that's fine, but it does kind of mean if your container changes to something else, then whatever's populating your database needs to run again. And if that only happens when your web app starts, then you need to restart your web app. Alternatively, I could have a custom database image, starting from Microsoft SQL Server image that's got all the stuff I need, but I would bundle my schema scripts, or I would bundle a DAC pack, and as part of my image, I would have it set up so when you run a container, it deploys the schema. And if I did that, then I wouldn't need to restart my web app because the data is part of the container. The initial data and the schema is part of the container. So I would be able to just connect directly. Okay, so kind of key takeaways from doing this stuff. At the moment, you can't run cross-platform containers. So I can't run a Windows container on a Linux host or a Linux container on a Windows host. So Microsoft are adding Linux container support to Windows, but that isn't gonna come good till the end of this year, maybe next year. So at the moment, and that doesn't give you all the benefits that you get from running on a native Linux host. So what Microsoft are doing with their ability to run a Linux container is they'll have my Windows host, I'll have Docker running on Windows, and if I want to run a Linux container, I'll get my Linux container with a really thin virtual machine underneath it. So I'm going to get a Linux virtual machine that just hosts my container, and then they can all play with the other containers that are running on that host or on that swarm. So we haven't even seen any tech previews of that yet, but that's going to come later in the year. When we do, we can start looking at the performance impact and security questions and that sort of stuff. But even if that works really nicely, it's still not going to give you things like the cost benefit of having a genuine Linux server, especially if you're in the cloud. So think about Linux running on Linux, Windows on Windows, certainly for the time being. If you're going to adopt some of the Linux technology that's out there, there's potentially a huge cost benefit to running in the cloud. And when you've got the option to add in all these bits and pieces that are either native Linux and don't work at all on Windows, or native Linux and work better on Linux than they do on Windows. And there's that stability point in there. So when you start moving your applications to Docker, what you've got is a bunch of servers that have the operating system installed and Docker and nothing else. So my virtual machines just had that, Ubuntu and Docker, or Windows Server 2016 Core and Docker. That immediately reduces the surface of stuff that you need to update and maintain anyway. But if it's a Linux server, then the chances of you having to do an update that's going to mean a reboot are much smaller. And by doing this with Docker, it lets you get all these great Linuxy stuff without having to dig deep into the world of Linux. So once you've set up your server running Docker, or if you use like a script on Azure, then you don't even need to do it yourself. It does it all for you. You're just managing Docker. You're just managing containers and nodes and swarms, and without having to dig deep on how these things are starting, how you get to the logs, how you check how hard the processes are working. All that stuff's coming from the platform, and you can treat everything in exactly the same way. So it kind of gives you all the benefits of all this Linux stuff. So I've shown you Elasticsearch and Kibana and NATS, SQL Server, and then also things like Nginx. So I could put that proxy in front of my web application now, just by running it in a new container on my same swarm. That's the entry point. It does all the caching. It does all the SSL, whatever else I need to do. I could replace my message queue with Redis if I wanted to, because I've got a Linux node that's doing that now. And if I wanted to, I could spin up GitLab and manage my whole deployment and CI process running in a container and get everything in the same way. And I wouldn't have to dig deep and become a Linux guru to make all that stuff happen, because I'm just running containers that somebody else owns and somebody else looks after. So, for instance, the Nginx image and the GitLab images, they're owned by those teams. So the Nginx guys build that image, so you know it's going to be production quality. Okay. And the next thing, so if this stuff's interesting, then up on, this is our short URL thing, Dockerly, without the E, Dockerly /labs. On GitHub, we got a whole load of self-paced labs that you can do. Some are Linux, some are Windows. There's a SQL Server one there if you're interested in that DAC pack bundling and being able to run a container that's got your schema. There's one that walks you through all that stuff. Our next conference is coming up in October, Copenhagen. You can get a t-shirt like this if you go, and you'll see me there. And that's me on Twitter. So I'm always, like, this is literally my job. So I'm always doing samples about stuff, showing you how to do interesting things, and tweeting about it. So you can get me on Twitter. So I'm a little bit short, so I'm happy to take questions. But other than that, thank you for listening. You don't have to ask a question to get a sticker. There are lots of stickers and Pluralsight passes and other bits and pieces too.